Hey everybody, thanks for taking time out of your busy schedule to come check out my talk. Today we're going to be talking about the attack that almost everybody knows about and has heard about, but we really don't talk about too much anymore. So a little bit about myself. My name is Robert Surace. I am a security consultant on the attack and penetration team here at Optiv under the threat management branch. I have a little over 12 years experience in IT altogether, and my background is in network and systems engineering. And these days, I focus on penetration testing and social engineering. When I get a bit of free time, I like to ride my motorcycle and race it. So, why are we here again? We're to discuss the classic man in the middle attack and why they probably still work, specifically ARP spoofing or ARP cache poisoning and rogue DHCP servers. So, a little bit of a story and a story about what prompted me to do this talk. Uh, I was engaged in a real life penetration test for an Optiv client. We had a 5-day testing window, and on day 4, still no foothold. Now you can imagine on day 4, I was getting a little bit nervous, wondering how this test was going to turn out with no initial access. Um, I was getting a little bit worried about that. So, a little bit about the attack scenario and the perspective. This was an internal penetration test. I was working from a remote testing device. This was on an unauthenticated to the user segment or the user network, and we were simulating a drop device or an insider threat. So some of the things that I did attempt, responder, using man in the middle 6 uh, to get hashes and relay them, printer passback attacks, password guessing, trying to detect and find exploitable software, looking for leaked data, any type of misconfiguration that I could use, and looking for any unprotected asset. However, I had no luck and no dice on finding anything there, which is why we are here talking about this today. This was the attack, so old that I forgot about it. ARP cache poisoning. I think this was probably the first quote unquote hacker attack that I learned about when I was going through school, um, learning about information systems. So, when performing ARP spoofing, we want to be careful because ARP spoofing can cause network instability or denial of service if it's carried out incorrectly or hastily. You really want to take your time and be patient when performing this attack. And you also want to choose the correct tooling for your needs. So getting back to the story, was on this client gig, and day 4 rolls around, and I start thinking, what is the attack surface? What can I touch? I've tried everything else. I've tried the typical foothold attacks. What else can I do? And I started thinking about ARP spoofing, and I thought to myself, well, we really don't do that too much, and I don't want to cause any issues in the client network. And so I started to look at what was available to me, and started looking through the newer tooling, and started going down the path to perform an ARP spoofing attack. So in this screenshot here, you can see this was the end result of the ARP spoofing attack. I had used this tool that we're going to be talking about to perform the ARP spoofing attack, but also within this tool, there's also a module that allows you to sniff the network data, and it would also parse the network data for you in most cases. So if you see in the top right, we have an HTTP post request. This was actually a login, and you could see the post data down the bottom, and you could see a username and password. It just so happened that this username and password was a domain account. And lucky for me, within an hour, I was domain admin. So let's talk about ARP basics and why this protocol is vulnerable. ARP stands for Address Resolution Protocol. This is the layer mapping of the layer 2 MAC address to the IPv4 IP address on a network. This is essential for IPv4 network operation. So looking at some packets, what happens when your computer gets plugged into the network? Well, we have this Apple device here. You can see the very first packet in this packet capture. The device sent out a gratuitous ARP request. Basically, what this is a packet that is broadcast and it says, hey, I'm new here. I'm new on the network. I got this IP address and here's my MAC address. So if anybody wants to contact me, this is how you do it. The next packet down the line, our same computer is broadcasting and it's asking, hey, who has 192.168.10.1? This just happens to be the default gateway. Can you tell me here at 192.168.10.115, which is our IP address? So basically, our computer is asking, what is the MAC address for the default gateway? Next, our Fortinet gateway comes back and tells us that I am the default gateway at 192.168.10.1, and here is my MAC address. So there's also this thing called the ARP Cache or the ARP table, and this is on hosts and switches, and this is a table that gets saved onto a computer or host so that each time you need to contact a computer on the local subnet, you don't need to go out and send ARP requests over the network. Usually these records expire out of the table after a set amount of time. So why is ARP broken? Or why is the security broken rather? Basically, it's unauthenticated and the packets are broadcast. So there is no authentication mechanism saying that when a computer either replies and says, hey, I'm this IP address to this MAC address, or when a computer comes onto the network and sends that gratuitous ARP request, there's no authentication mechanism saying that that is in fact me. This is where an attacker can take advantage of the insecurity in this protocol. So a little bit about the tooling. There's a number of ways you can perform this attack. There are some classics here. ARP spoof. This is built right into Kali Linux, if you're familiar with this. This is kind of an a la carte tool. This basically just does the ARP spoofing piece to capture any data and forward it, or to reconstitute any data, you need separate tools. There's this other one called Seth, which is really cool. I've used in the past. It combines ARP spoofing along with an RDP in insecurity that allows you to steal clear text credentials from RDP sessions. Man in the Middle framework is another good one to know about. Kane-Enable is a classic. It's a Windows-based tool. And BETTERCAP, which is what we're going to be discussing today. And BETTERCAP 2.x. So, as I mentioned before, ARP spoofing can cause some network instability. However, using tooling that is more modern in nature, and this tool is written in Go, which is a compiled language that's not going to be slowed down as much as an interpreted language. Uh, it also claims to be highly optimized and will not bottleneck the network when utilizing the proxy modules. Here's some screenshots of the help menus and some of the modules that are available within this tool. This tool is not just an ARP spoofing tool. There are many very cool attacks that can be performed with this tool. However, we're only going to be covering one today. So let's set up this attack. And this is something that you guys can do within your test network to see if you're vulnerable. If you have protections in place, then you know that. Well, you can test them this way, or you can just test it if you don't know that you have protections in place and see if it is possible. So, starting out, we have this module called RECON. We turn it on initially, and you'll get the syntax to this tool pretty quickly, and it's pretty simple. Net.recon on is the way you turn on the module. What this does is it imports periodically the ARP cache or the ARP table from the host into the tool so that we can see and learn what IP address, what MAC address is available on the network, and also what broadcast bytes we can see that are sent or received last time that the host was seen. And you can also see this by issuing the net.show command. Before we just pick a target and start the attack, we really want to choose a target that is, sending some data over the network. We want an active target because, again, this is a man in the middle attack. We want to redirect the traffic flow from the victim to the host or to the attacker so that we can sniff and steal any credentials or valuable information. So in this case, looks like 10.118 is going to be a viable target here because it was seen very recently and it had also sent the most amount of bytes. So let's set up the ARP spoofing module. There are a few options that we need to set up. We need to set the target. We need to set full duplex to true because we want to intercept traffic both coming and going from the host. We want to set spoof.internal to true to let the tool know that it is okay to intercept internal traffic. And then issuing the get arp.spoof.star command is going to read back our configuration to us and make sure it's okay so we can review that. Without a way to read the traffic or capture the traffic, the ARP spoofing attack would kind of be useless. So another really cool feature of this tool is called the SNIFF module. And the SNIFF module does a few things. It allows us to output the traffic that we are man in the middling to a capture file. And it also contains a parser within it. So if there is something blatantly obvious, like an HTTP login, and it's easy for the tool to see that that's what it is, it'll actually write that output to the screen. So again, a couple configuration items here. We're going to set a few things. We're going to set sniff.verbose to true. We are going to set the output file to somewhere locally so that we can go back later and read that capture file. And we're also going to set sniff.local to false. This is going to prevent any of the local host or attacking host data from being included in the capture file. Again, we're going to perform a get net.sniff.star command. This is going to return the configuration that we just set, making sure that we didn't make any errors here. So let's go ahead and activate those modules. Pretty simple, net.sniff on and arp.spoof on. This is going to turn both of these modules on. You can see in the second screenshot here, the tool automatically enables forwarding on your host. Without forwarding enabled, all the traffic coming to your host would just end there, and the victim computer would stop working pretty much. They wouldn't have access to anything in the network. It would be a denial of service situation. We definitely don't want that. We don't want to arouse any suspicion while doing this. And you can see in the third screenshot on the bottom here that we do see some traffic that's coming through. So more than likely, our attack is working. Now, it's important to be patient with this attack. It may take, a few different tries. Um, you don't really want to let this go for too long to avoid that denial of service situation. However, here's an example of opening up that capture file in Wireshark and doing a query for HTTP traffic. You can see in the bottom left of the screen, we discovered an HTTP post login. And within Wireshark, we were able to see the form items for username admin and password SCZ password. All right, so let's jump into a demo. I thought it'd be cool to show this here. So we're going to switch over to our console where we're running BETTERCAP. And on this local network segment, we have our attacking computer. We also have an iPhone running. We're going to generate some traffic from the iPhone. We're going to perform an ARP spoofing attack, activate the sniffing module, and we're going to browse to an HTTP login as well as some other unencrypted protocols and kind of just demonstrate this attack. So we can see what's running, what's not running. At the moment, just events.stream is running. First thing we're going to do is turn on RECON. Again, this is going to import the local ARP cache on the computer, the attacking computer. The net.show command brings up that table. And again, this is just the ARP table that is on the host itself. So if you actually turned on the probing module, the probing module will go out and do different types of queries like LLMNR or MDNS requests out on the network to kind of generate some traffic. We don't necessarily want to do that if we want to try to stay under the radar. It's just a little more loud. So if you find viable targets without turning that on, it's better to not do that. We're also going to turn off the events.stream. Whoops. And that's just going to turn off the events to the console. So it makes it a little easier to read our output and type. All right, I'm going to generate a little bit of traffic here on my phone so that we can identify it. There it is. Okay. So 10.130 is what we're shooting for. and we need to configure that ARP spoofing module now. And we do that with the set command, arp.spoof, and this application makes it pretty easy because there's tab completion. You could see what configuration options are possible, but right now we are going to set the target to my iPhone. And I should make a note here that you can do a range. You can do a full subnet using CIDR notation. However, you really only want to do a few hosts max. One is going to be optimal. You really don't want to be causing any denial of service situations on a network. Then we're going to set arp.spoof duplex. Sorry, full duplex to true, because we want to capture incoming and outgoing traffic from the host. We're also going to set arp.spoof internal to true. And that's going to capture traffic that's coming and going from the victim host that's going to other internal hosts as well, not just traffic that's going outside of our network or being routed. Okay, then we're going to look over the entire configuration we just set, as well as the other options, just to make sure that we covered everything. We do that by using the get command. We're going to do arp.spoof.star, and that's going to give us our options here. So that looks pretty good. Next, we need to set our sniffing options for the sniffing module. And if you're not too sure what options are available, again, you can just do the get command. So really, the only thing that we're concerned about here is the verbosity and the local flag, as well as the output. So let's set the output. This is going to be a capture file. And it's going to be somewhere on our local disk. All right. Then we're going to set the verbosity. And we're also going to, actually, it looks like default is false for local, so we're good there. Let's just look over the configuration now that we've made changes to it. Okay, I think I'm happy with that. So to activate these modules, we're first going to turn on the sniffing module because we don't want to miss anything. So we're going to do net.sniff on. And before we turn on the ARP spoofing module, I'm going to turn events.stream back on. And now we're going to turn on the ARP spoofing module. All right, and as you can see, we are up and running on the ARP spoofing module. I'm going to generate a little bit of traffic on the phone so that we can see. First, let's see if we still have visibility of the host. Okay, looks like it dropped out of our ARP table, so we may have to wait a minute here. All right, and it looks like just sending some ICMP packets to that host kickstarted that ARP process and allowed us to import the MAC address, and now the ARP.spoof module is up and running. As you can see, most of the traffic coming through right now is encrypted. It's HTTPS traffic, meaning we're not going to be able to decrypt it. However, there is some other modules within this tool that will actually allow you to strip SSL. However, if any type of SSL pinning is enabled, traffic just will stop working on that endpoint. And even if it isn't, they'll get a certificate error, while they're browsing the internet. So, not the best way of going about it. The best way of performing this attack is basically lying in wait for them to access insecure application. So, I'm going to go and I'm going to go to an HTTP login, and we're going to input some data. And then we're going to go to our capture file and we're going to view that data. Okay, so real quickly, we're going to turn off the events. Oops. And we're going to scroll back up here because you can see that we did, in fact, capture an HTTP post request. And the application was smart enough to detect that. However, it does not see any of the post data, or it's not actually displaying it on screen because I don't think it's detecting an actual username and password. However, that's not an issue because we have the full capture file that we can go back and reference. So I'm also going to make a request, and as a demo, we're going to pretend that on this phone, there is an admin software, and this admin likes to connect to their LDAP server. LDAP, by default, is, of course, not encrypted. So I'm going to go ahead and attempt authentication to it. And now that I think we have what we need, we're going to go ahead and stop the ARP spoofing process. Okay, here we are in our capture file utilizing the Wireshark tool. We know that we actually went and performed an HTTP login. We know that it was unencrypted. But for instance, if we wanted to learn what else was accessed over the network, we could go to the statistics menu and look at the protocol hierarchy. I'll switch this over so you can see. Within the protocol hierarchy, we can see what protocols were actually used in this capture file. So here we can see we had hypertext transport protocol. And we can also even see that there was form URL encoded. So if we select this and click apply as filter and selected, it's going to take us to that exact data. However, I also see the lightweight directory access protocol here. These are two things that we might want to check out. So let's go ahead and do that. So here we see we have an LDAP bind. And within this data is the actual bind request. And not only does it include the full context of the user, it also includes the password. Now, just imagine if you're using an Active Directory management tool or an LDAP management tool on your phone, and you're connected to your local network segment, or you're pretty much anywhere else. And an attacker is also connected to that same network. You can see how this could be no good. Let's also go back and look at that HTTP traffic. So again, here we see a GET request to a login form. And here's the actual post request. Within this data, we can see the username and the password. And this is just going to enable a user to steal these credentials and use them for no good. So we're just going to touch on rogue DHCP servers. We're not going to really go into detail too much. There really aren't too many tools for this, basically for the reason of you can pretty easily just set up a DHCP server on the same network segment as another DHCP server. DHCP is first come, first serve. Again, it's kind of the wild, wild west. If a computer sends a broadcast packet and says that it needs an IP, it's pretty much going to be whatever gets to it first is going to have its configuration set. It's also not authenticated. It's also broadcast traffic. This is just like the ARP protocol. We can set options such as the default gateway and the DNS servers. So if we are in a local network segment and we wanted to set options such as the default gateway and the DNS server for endpoints on that subnet, we could set them to point to us and capture all traffic passing through them. For DNS, we could perform DNS spoofing attacks, and when someone has queried something for an internal domain, we could redirect them to us as well, capturing credentials, password hashes, and so on and so forth. So let's talk about countermeasures. Pretty much every layer 3 switch out there has these countermeasures built in, but almost every single one of these switches has these countermeasures disabled by default. So it's a good idea to set these up in a lab if you have the means to test these before going into production, obviously. There really isn't too many drawbacks to these, but there is a little bit of design considerations when you're implementing these. First being DHCP snooping. Quite simply, it is a security feature that acts like a firewall between untrusted hosts and the trusted DHCP servers. So basically, in this case, you would set up a trusted DHCP server, and the switch would build a database of what is in fact the mapping of what it gave out, what the DHCP server gave out in terms of leases, and what those leases entailed in terms of MAC address to IP address. And then there's also this feature called dynamic ARP inspection. And this is going to correlate the IP address to the MAC address mappings collected when the DHCP snooping is enabled. So it's going to take advantage of that database that was previously spoken about. A little bit more detail, DHCP snooping. Again, it builds and maintains that DHCP snooping database. Contains information about the untrusted hosts with leased IP addresses. It utilizes the DHCP snooping binding database to validate subsequent requests from untrusted hosts. And then it's going to go ahead and filter and or rate limit this traffic. Dynamic ARP inspection, again, it's going to intercept all ARP requests and responses on untrusted ports. It's going to verify that these are valid IP to MAC address bindings before updating the local ARP cache and before forwarding the packet to the appropriate destination. If it isn't valid, it's going to drop the packet. This is a great protection. If your switch has this, I would urge you to enable it. That pretty much wraps up this talk. I hope everybody listening and tuning in got something valuable out of this. And I hope you have a great day.